Right, so this video covers the last two examples for this section, 3.3, applying the first derivative test, and this is going to be two examples involving trig functions. All right, so at this stage, assuming you have seen the other videos, so number 41, so to apply the first derivative test, that means we basically need to determine the relative max and relative min. And in order to do that, we need to first find our critical numbers. And to find the critical numbers, you have to find the derivative. So the first thing I'm going to do is find f prime of x. So find f prime of x. All right, so that's going to be equal to the derivative of x is 1, and the derivative of sine is cosine, so it'll be 1 minus 2 cosine x. All right, that's the derivative. I'm going to circle this because you'll be using that later on. All right, after you find that, then you have to determine the critical numbers. And basically critical numbers are either values in which its derivative does not exist or values in which its derivative is equal to 0. Cosine is continuous and its derivative exists everywhere, so there's no value x for which cosine does not exist. So we only need to focus on values for which its derivative is 0. So find any x where f prime of x is 0. So we set 1 minus 2 cosine x equal to 0. And I would subtract 1 from both sides. You have negative 2 cosine x equal to negative 1. And then divide by negative 2. So you have cosine x is equal to 1/2. Now keep in mind our interval, our domain, is 0 to 2 pi with parentheses. So we're restricted to that. And within our domain, if you look at the unit circle, the values in which cosine is 1/2 occurs when you have pi over 3 and 5 pi over 3. So there's two critical numbers. And I'll use C1 for the first one, that's pi over 3. And then C2 for the second one, 5 pi over 3. All right, so that's what we need to find. So we found our critical numbers. Now I'm going to apply the first derivative test by finding intervals of increasing and decreasing, and then from there determining what's relative max and relative min. All right, so now I'm going to find intervals of increasing or decreasing. All right, so our domain is 0 to 2 pi. And we have the parentheses around there. We have two critical numbers. We have pi over 3. And then 5 pi over 3. So we're going to have the following intervals. So we have the interval that goes from 0 to pi over 3. We're going to have the interval that goes from pi over 3 to 5 pi over 3. And then we're going to have the interval from 5 pi over 3 to 2 pi. All right, right, now we have to pick a test value from each interval. And I'm going to pick the following test values. Let's see, so I'll do that in red. So for the first interval, I'll use pi over 4. That's in between 0 and pi over 3. All right, and then second interval, I'll use pi. That's in between pi over 3 and 5 pi over 3. And then a value that's in between 5 pi over 3 and 2 pi, 7 pi over 4. All right, now plug each test value into the derivative. And that's where I circled the derivative was 1 minus 2 cosine x. All right, so the first value is pi over 4. That's going to be 1 minus 2 cosine of pi over 4. So that's 1 minus 2 times the square root of 2 over 2. One minus square root of 2, and the point is that it's going to be negative. We only care about the sign. So this is going to be negative. And when its derivative is negative, that means the function is decreasing. And that came from the interval 0 to pi over 3. So one of our intervals is decreasing on 0 to pi over 3. Again, we don't care about the actual value, we just care about the sign. So I just know 1 minus square root of 2 is going to be a negative number. So the second one is pi. That's going to be 1 minus 2 cosine of pi. Well, cosine of pi is negative 1. That's 1 minus 2 times negative 1, which becomes 1 plus 2, which is 3. And so that's going to be a positive number. And when its derivative is positive, that means the function is increasing. And that's the middle interval that came from pi over 3 to 5 pi over 3. That was where my test value came from. All right, so we have one more interval. You can probably guess what it's going to be. Probably going to guess that I would guess it would be decreasing just based on this alternating pattern. It's not always going to be like that, but at least intuitively, I would expect it to be switched to decreasing. But that's not necessarily going to be the case all the time. So you're going to still have to check. So the third value was 7 pi over 4. It'd be 1 minus 2 cosine 7 pi over 4. Well, 7 pi over 4 with cosine is square root of 2 over 2. So this would be 1 minus 2 times square root of 2 over 2. And the point is that's 1 minus square root of 2, so that's going to be a negative number. All right, that came from the last interval, 5 pi over 3 to 2 pi. So that means it's decreasing on that interval. Okay, so those are my intervals of increasing and decreasing. And from here, I just need to determine, I can determine what the relative max and relative min values are. Okay, so I'll do that down here. So our two critical numbers were pi over 3 and 5 pi over 3. We know for the first interval it was decreasing from 0 to pi over 3. So I like to draw an arrow down here to designate it's decreasing and within that interval. Then it goes increasing in from pi over 3 to 5 pi over 3. So I do an up arrow. And then it goes back to decreasing. All right, so it's negative, positive, negative for its derivatives. I drew the arrow down for decreasing and going up for increasing. So based on the pattern, if I go from decreasing to increasing, that means pi over 3. It's going to be a relative min. And then the second value from 5 pi over 3, it goes from increasing to decreasing. So this is going to be a relative max. All right, so last, I just need to find the y coordinates that go with these values. Okay, so you have to plug in the y value, so plug in these critical values into the original function. Because if you use the derivative, that's going to give you 0. It would be pointless to use the derivative. So I'm going to use the original function for this last step. And the original function at the beginning of the problem was x minus 2 sine x. All right, so for the first one, if I plug in pi over 3, that's going to be pi over 3 minus 2 times sine of pi over 3. And then you look on the unit circle, and what is sine of pi over 3? That's going to be square root of 3 over 2. So this is going to equal pi over 3 minus 2 times the square root of 3 over 2. And then you can divide out the 2's. So it'd be pi over 3 minus square root of 3. All right, and this is the y value. And so the point, our input was pi over 3. Our output is pi over 3 minus square root of 3. And we said that was a relative min. now we plug in the other one, 5 pi over 3, and we plug it into the original function, x minus 2 sine x. Okay, so original function was x minus 2 sine x. So that's going to be 5 pi over 3 minus 2 times sine of 5 pi over 3. And so to reference the unit circle, and sine of 5 pi over 3 is negative square root of 3 over 2. This will equal 5 pi over 3 minus 2 times negative square root of 3 over 2. All right, and we know the 2's divide out, but we have the negative times a negative makes positive. So this will equal 5 pi over 3 plus square root of 3. All right, that's our y value, or the output. So the point, our input's 5 pi over 3. Our output is 5 pi over 3 plus square root of 3. And recall we said that at 5 pi over 3 that was a relative max. So this is the relative max. All right, so as far as the answer to the question, these 2 points are the results we get for the relative min and max using the first derivative test. So this is the answer. All right, so that's number 41. Next one is number 47. All right, so number 47 is f of x equal to sine squared x plus sine x. And it's defined on the same interval, 0 to 2 pi. All right, and that's our domain. So what do? We first find the derivative. All right, and if you want, you could write sine squared x as so like this is the same thing as sine of x squared. And if I find its derivative using the general power rule, that's what I'm going to apply. In this case, u is sine x. So the derivative of sine is cosine. So u prime is cosine x. So when you take the derivative of sine squared x, drop down the 2, so it'll be 2 times sine x, to the 2 minus 1, which is the first power. All right, so that's 2 times sine x to the 2 minus 1. That's just to the first power, so I'm just going to leave it as sine x. And then times u prime. And u prime is cosine x. All right, so that is equal to 2 sine x cosine x. Okay, so that's just the derivative of that piece. So the derivative of the whole thing So f prime of x, we took the derivative of the first piece, sine squared x. That was 2 sine x cosine x. Then I take the derivative of sine x. Well, derivative of sine is cosine. So it'll be plus cosine x. All right, so that's our derivative. Now, we need to find critical numbers. There's no case in which sine or cosine do not exist. So we only focus on when its derivative is 0. So I set 2 sine x cosine x plus cosine x equal to 0. All right, I can factor out cosine. And that'll give me 2 sine x plus 1. That's equal to 0, and I have two cases. Case 1 is cosine x equal to 0. Well, when is cosine 0? And cosine is 0 at pi over 2 and 3 pi over 2. Oh, 3 pi over 2. All right, case 2 is the 2 sine x plus 1 equal to 0. All right, so subtract 1 and divide by 2. So you have 2 sine x equal to negative 1, divide by 2. You have sine of x equal to negative 1/2. And then I ask, where is sine negative 1/2 on the unit circle? And that's when x is 7 pi over 6 and 11 pi over 6. All right, so I got 4 critical numbers. So this and these. So there's 4 critical numbers. Now I find my intervals of increasing, decreasing. Our domain is from 0 to 2 pi. And I just go in order. So you have pi over 2 comes first. And then, let's see, so the next one that would come is 7 pi over 6. So I'm just going in ascending order, so 7 pi over 6. And then the next one would be 3 pi over 2. And then the last one, 11 pi over 6. So I have a good bit of intervals. So this one, that's 0 to pi over 2. And then I'll just do them all, actually I'll alternate colors. So I'll do green for this one. That's pi over 2 to 7 pi over 6. Seven pi over 6 to 3 pi over 2. Then I have 3 pi over 2 to 11 pi over 6. And then the last one is 11 pi over 6 to 2 pi. All right, so I have to pick some test values from each of these intervals. We have 1, 2, 3, 4, 5. So we got, yeah, 5 sub-intervals, which means I'm going to have 5 test values. And for each test value, I'll just use purple. So a value that's between 0 and pi over 2. That's up to my choosing. I'll choose pi over 4. A value that's in between pi over 2 and 7 pi over 6 would be pi. A value that's in between 7 pi over 6 and 3 pi over 2, you could do 5 pi over 4. A value that's in between 3 pi over 2 and 11 pi over 6, I can do 7 pi over 4. And then there's no convenient value on the unit circle that's in between 11 pi over 6 and 2 pi. So this is x5. If you put 11 pi over 6 in the calculator, let me find that real quick. All right, so 11 pi over 6 is approximately 5.7595, and it's like 86 and keeps going. So a value I can pick that's more than that, I could choose 5.8. And that's my choosing as long as it does not exceed 2 pi. So I have 5 values. I have to plug these into the derivative and see if you get a positive or negative number. Okay. And our derivative, I didn't circle it, but we have 2 formats we could use. So we have this format, or I could use its factored format. So I could use this one, or I can use this one. I'm going to use the factored format, cosine x times 2 sine x plus 1. That's just my decision to do that. I think it's easier to plug it into that. It's less stuff to calculate. All right, so I have to do each test value. So for pi over 4, that's going to be cosine pi over 4 times 2 sine of pi over 4 plus 1. All right, so cosine of pi over 4 is square root of 2 over 2. So this would be equal to square root of 2 over 2 times 2 times sine of pi over 4. Well, that's going to be 2 times square root of 2 over 2. And then plus 1. And we just care about the sign. We only care, is it positive or negative? So we have everything's positive in here. So it's going to result in a positive number. What does that tell us, right? When a derivative is positive, that means the function is increasing. And it's increasing, and that was the first sub-interval of 0 to pi over 2. So it's increasing on 0 to pi over 2. All right, and we do the same process for the other ones. And I'm going to pause the video and work it out, and then I'll show which intervals are going to be increasing and decreasing. All right, so I paused it and found these myself just to save time in the video. Again, you just plug each of these test values into its derivative, record, and the sign is what matters. Here are the results I get if you want to pause it and write this down. So for the first test value, it came out to be a positive number, which means you have increasing on that first interval. Then for the second test value, it came out to be negative, so that means decreasing. And so you see this altering of increasing and decreasing that remain consistent. Right, so that's the intervals of increasing and decreasing. All right, and so now we're finally going to get to the part where we determine relative min and max. Okay, so let me draw a number line. Let's see, so we had pi over 2, 7 pi over 6. Three pi over 2, 11 pi over 6. All right, so that's all of our critical numbers. All right, so the first interval, it's increasing. So it's going up. And then the second interval from pi over 2 to 7 pi over 6, it's decreasing. So then it's going down. So that means I have a relative max at pi over 2. Let's see, so that's it. I'll say C1 for the first critical number. All right, so from 7 pi over 6 to 3 pi over 2, it was increasing. And then it goes from this one is decreasing, and then ends with the last interval is increasing. So we determined pi over 2, it's a relative max. At 7 pi over 6, since it goes from decreasing to increasing, that's relative min. Three pi over 2 goes from increasing to decreasing, so that's relative max. And then 11 pi over 6 is a relative min. Okay, we're almost done. Just finally need to check what are the y coordinates that go with each of these. So last, we need the y coordinates that go with each of these points. And again, for this last step, you always have to use the original function. For the original function, is f of x equal to sine squared x plus sine x. All right, so I have to plug each one of these into that, and I'll demonstrate plugging the first one in, see what you get, and then I'll pause the video and write down the results I get for the other ones to save time. So the first one's pi over 2. So that's sine squared pi over 2 plus sine of pi over 2. Well, on the unit circle, sine of pi over 2, I believe is should be 1. I'm blanking out here for a second. Let me get the unit circle. Yeah, sine of pi over 2 is 1. So this will equal 1 squared plus 1. So that's going to be 2. All right, so that's the output. That's the y value. So that means at the point pi over 2 comma 2, that's a relative max. Okay, so that's the, so we want the whole point itself. So we plugged in pi over 2, our output is 2. All right, I'm going to pause and write the other ones and show what I get for the other ones. Okay, so I showed how I got the first value. When I plugged in pi over 2, I got 2 as the output, so that gave me relative max pi over 2 comma 2. Now the rest I went ahead and worked out. And these are the corresponding values I get. And I determined, well, it goes relative max, relative min, relative max, and relative min. And that's the answer, is looking for these extrema. All right, and that's the supporting work that I showed. So if you want to pause the video, you can and write down that work. I just didn't want to spend a lot of time. It's just plugging in the value into the function and getting its output. All right, so that is it for this section. The next section is going to be 3.4.